Hello students, let's read this problem. A machine component is suspended from a rolling crane which can move along a horizontal girder. The component is to swing no more than 3.8 meters horizontally when the crane is suddenly brought to rest. Determine the maximum allowable speed V of the crane. Okay, so here is the diagram. Uh, what is the component? This is the component, right? And what is the crane? This is the crane. I hope you can see this. This little faint, but should be okay. Or should I make it black? Okay, so so this is component, this is crane. Now see what is happening. The crane is moving in this direction. The crane is moving in this direction, and obviously the component also will be moving in the same direction, right? Because the component is hanging, so the velocity of the component and velocity of the crane will be same. Fine. But what you are told is that the crane will be suddenly brought to rest. When crane is suddenly brought to rest, will the component also be suddenly brought to rest? Will it just stay where it is? Just think about it. Pause this video and think about it. Okay, welcome back. So when crane is stopped, the component is not going to immediately stop. It would swing a bit, right? It would go ahead because of the inertia. It was moving at certain velocity v, and the crane has stopped, but there is a string. It's not rigidly connected to the component is not rigidly connected to the horizontal girder or the crane. Girder is in which the crane is moving, but the crane is moving at velocity v. So the component will swing. It will, when the crane is stopped, brought to rest, the component will travel ahead. So it will reach a certain point, and then it would come back. It will be like a pendulum, right? So it will reach a certain point where its velocity and that point, right? They are told that it can move horizontally only up by 3.8 meters. The velocity of the crane should be such that when it is stopped, when it is suddenly halted, the component, which will act like a pendulum, will move not more than 3.8 meters, right? So let's imagine that because of this let's say stoppage of or halting of the crane, we will say that the component now has moved to right. So this component now has moved to right when the crane is stopped, and let's say that it is somewhere here the component comes, right? Here is where component comes, and you are told that it has to move, the velocity v should be such that this component has to move only 3.8 meters horizontally. That means this distance is 3.8 meters. Okay, and please note that although it might not sound that, but this is the length of the component. This is the length, right? This is the length of the component is this 9 meters, right? And now when it is moving towards right, this is also 9 meters, right? This is also 9 meters. Now you are told that so basically the position 1 of the component is this. We can say this is position 1 and this is position 2. What you are asked is, you are asked to find out the velocity of the crane, or velocity which is also velocity of the component when at position 1. So v is the velocity of the crane and velocity of the component. Okay, now you want to find out this, and as I said, we will always just write that single simple equation of energy balance equation, work energy equation, whatever you call, basically law of conservation of energy, to solve this. And if you want to do that, let me first write a general expression. So we have these 2 points, right? So this is position 1 and this is position 2. I have written this twice, but this is position 1 and 2. So what is our equation? We will say that we'll write a general expression. At position 1, the body can have two types of energies. One, it can have say spring energy, okay, half k1x square. It can have potential energy, half mgh1. It can have kinetic energy, half mv1 square, right? And plus there could be some work done if there is external force, minus the energy spent because of friction, Fr into d. This will be this will be equal to the energy possessed as position 2. And at position 2 also it can have spring energy, right? It can have potential energy and it can have kinetic energy, right? Now here if you compare these positions 1 and 2, there is no spring attached, right? The component is not attached with spring, so we can just remove this spring. So this is gone, right? From both the sides. At 1 and 2, at position 1 and 2, there is no spring. Now look at the potential energy, right? The potential energy at 1 and potential energy at 2. We can say that the potential energy at 1, we can say, if we choose the datum, this is the datum, right? This is the datum. If this is the datum, then we can say the potential energy at 1 is 0, and potential energy, to find out potential energy at 2, we have to find out this distance. I'll call this h or h2, right? So when position is 1, it's because the datum is what we are choosing at when this component it has position 1, that's a datum. That means h1 is equal to 0 because we are choosing that as datum, and h2 is to be found out. Okay, so we can say, if you look at the second term in this energy equation, this term, I'm saying this term will also go because we are choosing first position as the datum and h1 is equal to 0. So that is gone. Now what about half mv1 square? Obviously we want to find out that velocity v. It has velocity v at position 1, and so we will call this as instead of v1, I'll call it as v because they have given it as v. So I'm writing the equation. So this is something which this energy will be there. Now at position 1, is there any external force acting on the body, so that from 1 to 2, when the body moves, there is some work done which is equal to energy supplied to the body? No, there is no external force acting. So this is also gone, right? Now what about friction? When it is moving from 1 to 2, you could say there is some friction offered by air, but it's not mentioned. Air will offer very small friction and it's not mentioned. So this frictional energy is also gone, right? Now if that is true, then our equation is reduces to, please note, I'll write it again. Our equation is okay. So this is, I'm writing this equation. Please note, I am taking this thing half. I'll write this as half mv square. Okay. Instead of v1, I'll say v because they are already. This is the velocity v. Okay, is equal to, right, mgh2. Now this mgh2 is this h2. Please note the height, right? We want to find out that height. We will do that mgh2, right? And what about the velocity at position 2? Will it have velocity at position 2 when it reaches the position 2? Please note it will be 0. Why? Because it's going to maximum that point, right? It's not going beyond that. So it will again come back. It's like a pendulum. It will again come back. But the moment it has reached, before it starts traveling back, its velocity has become 0, right? So this term, it doesn't have any kinetic energy. So this is 0. So our equation is very simple. Please note, at position 1, the body has kinetic energy. At position 1, it has potential energy. What you are asked now is to find out V2. To find out V2, what do you want? To find out V2, you please also note that M from both the sides are gone. So we don't need the mass of the component. M is gone, right? So all that we have is, now you know that V square is equal to 2GH2. That means V is equal to root 2GH2. Now, how do you find out this H2? This is our H2, right? This is our H2. Please note this H2. To find out H2, we can use this. Can we use Pythagoras theorem? Yes. Here this length is 9, right? If I call this A, this is B, and this is C, and if we find out AB, right? If we find out AB, then you can find out H2, because total length is 9. 9 minus AB. 9 minus AB is H2. To find out AB, we can use Pythagoras theorem. So AB is equal to under root AC square, please note, AC square minus BC square, right? And AC square is how much? 9 square. BC is 3.8. That's the maximum horizontal distance it can move. So it is 3.8 square, right? So this is going to be AB. Now once you have AB, then 9, now this is total 9, please note, this is 9 minus AB, please note, this is B, this is A. So H2 is equal to, right, H2 is equal to 9 minus AB, this is H2, this is, sorry, this is your, from here it is your H2. So 9 minus AB, and AB can be found out from above, and you can, am I right here? Yes. So we can find out AB from there, and we can find out H, and that H is going, H will be, height is going to be, let me find out that, 9 AM, that is this AB is, AB you should get as 8 point, so here AB 8.158 meters. Please note AB is 1.8 point, yeah. Okay, now this is what we have found out. Now we can find out H2, right? We can find out H2, which is equal to, we can say this is, yeah, 9 minus 8.158, 9 minus 8.158, and this will be, okay, let's keep it as 9 minus 8 point, this thing, and we will find out V is equal to, now straight, V is equal to root 2 GH2, and this will be 9.8 into H2, and H2 you can find out from here. So 9 minus 8.158, just find out that value of H2, and you should get V as 4.064 meters per second. Okay, 4.0. So this is the velocity V. The crane should have a velocity V, so that when it is stopped suddenly, it will go, the component will travel a horizontal distance of no more than 3.8. Please note, no more than 3.8. I hope this is clear. And basically, you remember that we have started only with this general equation and substituted the values, right? Thank you.